Find the derivative of x squared plus 4xy plus y squared equals 6. Then evaluate the derivative at the point -1, 5. So we have the implicit equation x squared plus 4xy plus y squared equals 6. It's not solved for y in terms of x. And therefore, to find the derivative, we can find it by just taking the derivative of both sides, what's known as implicit differentiation. And then we'll indicate that by a prime on both sides. On the left side, the derivative of the first term will be a power rule and be a 2x. The second term is the product of 4x times a y. So we use the product rule. The derivative of the first, the 4x, will be a 4 times the second left alone, y, plus the first left alone 4x times the derivative of the second. The derivative of y is 1, but then because it's a y term, we get a y prime every time we take the derivative of a y term. Plus, the derivative of y squared will be a power rule, bring down the power, subtract 1 from it, but because we just did the derivative of a y term, we again get a y prime. On the right side, we have the derivative of 6, which will be a 0. So we have 2x plus 4y plus 4x y prime plus 2y y prime equals to a 0. We want to solve for y prime here. And that's accomplished by isolating the y prime terms. We have two terms that have y prime and two terms that do not have a y prime. These do not have a y prime. We will move those to the other side by subtracting them over. So we have the 4x y prime plus the 2y y prime equals to, subtracting those over, negative 2x minus 4y. We can now factor the y prime out on the left side, and that will give us 4x plus 2y equals negative 2x minus 4y. And we will divide negative 2x minus 4y divided by 4x plus 2y. We have common factors in the numerator and denominator. In the numerator, we have a negative 2 that can factor out. And that will leave us with an x plus a 2y. And in the denominator, we have a common factor of a 2. And that will leave us with a 2x plus a y. The 2's can cancel. And that negative can sit out front. So we have the negative of x plus 2y over 2x plus y. There's the simplified version of the derivative y prime. From here, we can evaluate this at the point. This will be the x-coordinate and this the y-coordinate. We need both coordinates to plug into implicit derivatives. Generally, they have both x and y in the result. So y prime will equal the negative of, plugging in a negative 1 for x, we will have a negative 1 plus 2 times plugging in a 5 for y, all over 2 times a negative 1 for x, plus and a 5 for y. And now we just want to simplify this. So we have the negative of, in the numerator we have negative 1 plus 2 times 5, which is a 10. And in the denominator we have 2 times negative 1, which is negative 2, plus a 5. So we have the negative of, negative 1 plus 10 is a 9 over negative 2 plus 5 is a 3. And 9 divided by 3 is a 3. The negative just comes along. So we end up with y prime equals negative 3.